So here I introduced the standard free energy change, and that's important because the standard free energy change gives us a molecular understanding of the equilibrium constant. So the equilibrium constant K is related to the standard free energy change here by this expression. So R is the ideal gas constant, that's given here, and T is the temperature. And the standard free energy change here, delta G standard, is the standard free energy of the product and the standard free energy minus the standard free energy of the reactants. And the standard refers to the standard state, and that's indicated by this symbol here. And in later videos we'll talk about what the standard state is. It's usually a standard pressure. But much more about that later. Okay, so that's the relationship between delta G standard and K. So if we have this equilibrium reaction with this equilibrium constant here, what is delta G standard for this reaction at 25 degrees Celsius? So press the pause button, think about it, do some calculations, and when you think you have the right answer, press play. Okay, ready? All right, before we go on to the actual calculation, there's one answer here that we can eliminate right away. And that is this answer here, a negative delta G. The delta G standard cannot be negative if the equilibrium constant is less than 1. If delta G standard is negative, right, then you have minus a negative number, so you'll get a positive number up here. And if you have a positive number up here in the exponent, then K will always be larger than 1, and K is smaller than 1. Okay, so without doing any calculations, we can eliminate answer A. Now, as to the other answers, what we'll see is that there's really only one answer here that makes sense, but we'll talk more about this later. Okay, so to do the calculation, this is to emphasize what I said earlier, right? So negative delta G means a K larger than 1. As we'll see, this delta G standard is so close to 0, and that would apply an equilibrium constant that's close to 1. In fact, it's very small. And this is much too big for a bond. This is way too much energy to break an ionic bond, as we see here. Okay, so the right answer is this. How did we get to this answer? Well, if K is related to delta G like this, then we can solve for delta G standard and get this expression for delta G standard. So now we just need to plug in the values. So we have minus, here's the gas constant, and when we work with temperature, we have to always convert it to Kelvin. So 25 degrees is 298 Kelvin. And finally, we take the natural log of the equilibrium constant, and that gives us this value. This value is in joules per mole because the gas constant is in joules per mole. And so very often we convert this to kilojoules per mole. So we deal with more reasonably sized numbers. So in this case, 27.2.